Now we shall discuss about a priori algorithm. It is an important algorithm in data mining and data warehousing. Myself, I am Dr. Uma, professor in the Department of Computer Science and Engineering in Hindustan College of Engineering and Technology, Coimbatore. Now let us discuss about the basics of the a priori algorithm. What is an item set? A list of items together is called as an item set. If the list has k items in the set, it is called as a k item set. An item set can consist of two or more items, and if it occurs more frequently, we call it as a frequent item set. Frequent item set mining is an important activity in data mining. It is a technique used to identify the items that occur frequently in a transaction. For example, departmental store, the items that are bought together, bread and butter, are kept together in order to boost the sales of butter or vice versa. Similarly, people who buy laptop also buy antivirus software. These are certain examples. Now let us see what is a frequent item set. A set of items is said to be frequent if it satisfies a minimum threshold value for the support and confidence. The support shows the transactions with items purchased together in a single transaction, whereas the confidence shows the transactions where the items are purchased one after the other. We consider only those transactions which meet the minimum threshold support and confidence requirements for calculating the frequent item set in frequent item set mining. It offers us with a lot of benefits and provides us with advantages such as cost cutting and improved competitive advantage. There is a trade-off between the time taken to mine the data and the volume of data used for frequent mining. The frequent mining algorithm is an efficient algorithm used in data mining and is used to mine the hidden patterns in the transactions in departmental stores and in other fields as well, within a short period of time as well as with the less memory consumption. So it is considered to be an important algorithm in data mining. It is used to find interesting patterns in data mining. It is used to discover the relationships between the different item sets in a data set. The relationships between the item sets are represented in the form of association rules. Frequent pattern mining has many applications in the field of data analysis, software bugs, cross-marketing, sale campaign analysis, market basket analysis, etc. Now let us see what is meant by support and confidence. Support is defined as the number of transactions in which A appears divided by the total number of transactions. Confidence A given B is given as support of A union B divided by support of A. There are certain support levels as well as confidence levels that are set as threshold values for any application. Now let us see what is meant by association rule mining. It consists of two steps. In the first step, we find all the frequent item sets, and in the second step, we generate all the association rules from the above frequent item sets. The steps in the a priori algorithm are given here. What we do is, with the transactions that are available in the given example, we identify the number of occurrences of each of the items taken as a single count in the transaction. We then check out to see whether it is satisfying the minimum support level that is meant for the application. If it is satisfying the application support level, we take that into account or we ignore that specific item. Then with the available items, we identify the two item set and their counts, and we check out whether the two item sets are satisfying the minimum support threshold level. If it is satisfying, we take that into account, else we ignore that also. With those, we are then going for the 3 item set, 4 item set, likewise till k item set, wherein we don't have any other combinations, or whether the k item set count is equivalent to null. So till then we do this iteration. Now let us see an example in order to have a better understanding of the a priori algorithm. In this slide we have given the flowchart for the a priori algorithm. Let us move on to the example. This is the transaction table where T1 to T6 represent the transaction ID. Against each of the transaction IDs we have the list of items purchased against the transaction ID. Here we have the support threshold value set equivalent to 50%. Since we have 6 items here, 0.5 into 6 is equal to 3, which is taken as the minimum support level for any item. With this, we are identifying the number of occurrences of each of these items. There are 5 items listed out as given here, I1 to I5, and the count values of their occurrences are given here. For example, we could see that I3 is occurring in 4 of the transactions, 1, 2, 3 and 4. Likewise, we do it for the remaining transactions. Next, what we do is we prune the table based on the minimum support value equal to 3. So here I5 has got only 2 occurrences, we ignore this item and we go forward with these items alone. In this we take combinations of I1 to I4. They are I1 I2, I1 I3, I1 I4, I2 I3, I2 I4 and I3 I4. So the number of occurrences of each of these two item sets are given here based on the transaction table. So here we are taking the minimum support level 3. In order to prune this table, we are available with this particular table, I1 I2, I1 I3, I2 I3 and I2 I4. Next we move on to identify the 3 item set, and we are identifying the number of occurrences of each of this. In the transaction table we could see that only I1, I2, I3 is satisfying that. Based on this we are calculating the confidence level for each of these items. So here the confidence level is equal to support of I1, I2, I3 divided by support of I1, I2, that's equal to 75%. Similarly, we calculate for the remaining items and we find that we are available with these values of confidence: 75%, 100%, 75%, 75, 60 and 75. So we have to have a confidence threshold value of more than 60 in order to have these association rules. Since all of these association rules are having a value above 60, these association rules are considered to be strong. Thank you.